Okay, so on this question, they're giving us measure of angle 6 is 18x plus 208. So that'd be right here. 18x plus 208. And then they say the measure of angle 3 is negative 4x degrees. So that'd be right here. I didn't do that so well. Right there is negative 4x. And they want us to find x. So how do we do it? Well, the trick on this one is what do we do with those two formulas? Can we set them equal or is it something else? Well, to remember that, here's the notes. This is from the exam 1 notes right here. Put this in for you. So this is the exam 1 notes. Okay, and it tells us, see, you can see how it has the same setup, right? Two parallel, see how these are two parallel lines cut by a transversal, right? So that's what we're talking about. This, whoops, sorry, I went right on by. That's just two parallel lines, corresponding angles are equal. So what are we talking about? Well, basically, I think the easiest way to see it is with these z's right here. I call it the z test. So so you see how this little z here, these two angles A and B, or you can do a backwards z also, boom, 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 C and D, they will always be equal. The z test, so those are called alternate interior angles. I'm not going to quiz you on all those fancy names, just the z angles. The two angles the z makes, called z angles, those are equal. They're always equal, congruent. Now, more formally, it's all like, it's all right here. But anyway, I think z is the best one. Let's just go back to it. So we know the z angles are equal. So here's the easiest thing we can do. Just look for a z. So here's a z right here. Boom, 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 right? Like that. And so this angle and this angle, 3 and 5, have to be equal, don't they? So then this right here is also negative 4x. It's got to be the same. Is that making sense so far? Let me do that. Let me try to do that z in a big clear way. Boom, boom, boom. See that z right there? So those two angles have to be equal. That's what the z test is saying. The z test, alternate, z angles, this angle, or backwards, this angle and this angle are always equal when you got these two parallel lines. So, okay, so no, okay, great. You might say, okay, I got that, Mr. Chairman, but how's that help us? Well, now do you see what we can do? Now we know that these two make 180, don't they? Does that make sense? Because they're part of a straight line. Let me draw them again here. Right, I'll just put right here. Those two, they're the top of a straight line, so they have to make 180. So these two angles total 180 because they make they make the one side of a line. So they have to make 180 degrees. So, okay, so what does that mean then? Well, that means we're in business. That means we can take now the negative 4x, we can add to it the 18x plus 208, and the total has to be 180. So I just took the first angle plus the second angle, two formulas, they have to add it to be 180. So they're not equal to each other. They add up to be 180 on this one. Kind of interesting. So, okay, so what does that do? How do we solve this now? Well, we do algebra. Negative 4x plus 18x, that's 18 minus 4 is 14x. Plus 208 is 180. Subtract 208 from both sides. You know how to do all this algebra stuff. This is probably the easy part for you. Let's bring down the 14x equals, what's that, minus 28? Yeah. And then divide by 14. Last step. Boom. X is minus 2. So there it is, we got x. So it was all about, whenever you have these two parallel lines cut by a transversal, you look for the z's, and the two z angles are always equal. As soon as we got this down here, then we knew these two made a straight line, made one side of a straight line. So that's 180 degrees, right? That's halfway around. You remember that all the way around a circle is 360. So halfway around a circle is 180. So these two together have to make 180. We add them up to equal 180, and then we can solve for x. So there we go.